Okay. Now, the last type of connection is the fixity. The fixity is exactly like the fixity in 2D. I cannot do anything. I cannot rotate, I cannot translate. So if you have a fixity in 3D, the fixity will develop all types of reactions, 3 forces and 3 moments. Okay? So now that I am familiar,
دكتور،
yes?
فيك بليز ترجع تشرحي قبل اخر واحده ليه فينا نعمل روتيشن على اكس؟
Yeah. Let us consider the door. You have a door. Okay? Door is if you look at the extremity of the door you will see هيدي بنسميها هول المفصل تبع الباب. Okay? You have these that you put along this direction to support your door. Okay? Your door, because of these connections, can only rotate about the vertical axis, صح? Okay?
مظبوط.
Since you can rotate about this axis, this means that there is no moment reaction about this axis. انت هون اذا بتطلع بهالفيجر وين الاكسس هون. So for this type of connection, there is no moment reaction along this axis because you can rotate about it. Okay? But you have moment reactions for the two other directions. So this is a moment in Z and this is a moment in X, but no moment in Y because I can rotate about Y. إذا عندي هيدي الفيجر I can rotate about Z يعني هون ما في ام Z في ام X ام Y. Okay?
اوكي ثانك يو.
Well, okay. So now for equilibrium conditions, we can write 6 equations. Sum of x, sum of y, sum of z equals 0. And we select any point in space O. Sum of moment about O equals 0. This will give us sum of moment about x-axis passing by O 0. Sum of moment about y-axis passing by O 0. And sum mz passing by O 0. نحن when we don't mention the point بيكون الأوريجين of the system of the frame. يعني عادة بناخد الأوريجين وبنعمل sum of moment about origin equal 0. This corresponds to some mx, some my, and some mz equal to 0. بس you can select any other point in space. فيكن تاخدوا A, B, C. It doesn't matter. You select the easiest point for you and you do sum of moment about it. Then you will have sum of moment about x-axis passing by A0, sum of moment about y-axis passing by A0, and sum of moment about z-axis passing by A equal to 0. Okay. Now, sometimes in some cases we have supports more than needed. يعني I put support more than needed for equilibrium. In this case, we can say that the problem is redundant. Yani, since I am putting reactions more than needed, I cannot solve my system of equations. Example, if you have a beam, okay, and you are applying forces on it. If you put two pins at A and B, so I put a pin at A and I put a pin at B. And they ask me to solve for the external reactions. I have two unknowns at A. I have AX and AY. The same at B. For point B, I have BX and BY. So I have 4 unknowns and I can only write 3 equations. So I say I have equilibrium, but this system is statically indeterminate. يعني I cannot solve for my reactions only using static equations.
دكتور هو كان
اوكي
المفروض يكون بن ورولر.
مظبوط مفروض يكون بن ورولر. إذا كان بن ورولر I have only three unknowns لأنه إذا في رولر بدل بن هون I don't have bx will cancel out and I only have a pin and a roller. I can write three equations with three unknowns. Okay. Now, what do we mean by improper or partial constraints? Improper, يعني I am not selecting if you want. I can have only three unknowns, three equations, but the selection of support is not convenient. For example, if I take a beam and I put three rollers, if I put three rollers, am I able to satisfy equilibrium for any type of load?
نو لانه اذا اجت على الواي، عفوا على الاكس، بصير بيتحرك.
Very good. If I put a force here in x direction, what will happen? No, a roller cannot develop a reaction in this direction. The three rollers will develop vertical forces here. So they cannot oppose motion in x. So for this scenario, it's not possible to have equilibrium. Okay. Now, if I consider this is called improper constraint. Yani I have three equations, three unknowns, but when I write sum of x, and if I put here 10 kilonewton, and the condition for equilibrium is that sum of forces in x should be zero. I say it's impossible to have this because I have minus 10 and I don't have any reaction to oppose it. And is it possible to have minus 10 equals zero? Impossible. So it's not possible then to have equilibrium in this case. So I say that I have an improper choice of supports. Now, what do we mean by partial constraints? For partial constraints, I have, if you want, number of supports lower than required. And for example, if I have only two rollers, this is called partial constraints. I can have only equilibrium in particular cases. I can have equilibrium in this case if my force is vertical downward. If my forces acting are vertical and the net force is down, okay, so I can have equilibrium in this case because my rollers will develop upward vertical reactions in a way to cause equilibrium. Okay, in a way to cause equilibrium. However, if I put a horizontal force or if I put a force upward, I cannot have equilibrium. Okay, so in case of in case of partial constraints or improper constraints, okay, I can have equilibrium and I can have non-equilibrium. It depends on the load. Okay. And how we
دكتور
judge if we have equilibrium or not, we should put the equations of equilibrium and solve. And for example, if you have two rollers only and you don't have a force in x, sum of x equals zero is satisfied. So this equation is satisfied. I write the two other equations, sum of y equals zero and sum of moment equals zero, and then I can solve for the reactions. Okay. So to make sure that I have equilibrium, all equilibrium relations should be satisfied. Okay?
دكتور طيب بالفيرست اكزامبل يلي تبع ال A B،
Yes.
اذا حطينا نحن الرولر بدل وبس وعملنا فيرتيكال فورس وابورد، ما بيكون بيتحرك ساعتها؟
إذا في pin لا، لأنه البن will
بين
not
اند
allow
رولر،
translation in upper direction.
بس تبرم بتصير.
Uh, انت you mean the force is كيف هيك? You mean the force is
عشان
up?
عم
Yes,
yes
okay, I see. The roller, yes, I see what you mean. The roller, yes, the roller cannot develop a force that is downward. And if you solve and you get By negative, it's impossible. Okay. And the roller can only develop a reaction upward. It cannot develop a reaction that is downward. Okay. So if you have a roller and you get a negative force, you say it's impossible. Okay.
okay doctor.
So as we said, when a body has redundant support, the problem is called statically indeterminate. So I have equilibrium, but I cannot solve for my reactions. And if you will take after, you need other science to solve. Yani, for example, if you will take mechanics of materials, you will learn how to solve for problems that are statically indeterminate. You need to use a science other than statics to solve for your unknowns. But in the scope of this course, we are just responsible for statics. So if you have redundant supports, you say there is equilibrium, but I cannot solve for these reactions. Now, improper or partial, as we said, if I have two rollers, this is partial constraints. So it's not enough to have two rollers. I might have equilibrium in some specific conditions, but not in all conditions.
Doctor, يعني partial و improper is the same thing?
لا. Improper يعني number of equation equal in number of unknown. بس السelection للtype of supports is not good. يعني انت اذا بتحط 3 rollers, you have 3 unknowns, 3 equations, but can you ensure equilibrium in if you have x force in x direction?
No.
No. يعني انت it's true that you have number of equation equal number of unknown, but you didn't select your supports in a proper way. مش هيك بيسموه improper.
اوكي
Okay. بينما partial, the number of reactions is smaller than the number of equations. Okay. Let us solve this equilibrium problem. Rod AB is subjected to the 200 Newton force. Determine the reactions at the ball and socket joint and the tension in cables BD and BE. The ball and socket شو قلنا هي؟ It can only do يعني هون عندي this connection allows me to rotate in all directions, but I cannot do translation. So whenever they tell you have a ball and socket joint, then at A I have 3 reactions, AX, AY, and AZ. Plus I have 2 cables, يعني I have tension TBE and tension TBD. هيدا البروبلم شو partial, redundant أو improper؟ How many
عندنا
reactions؟
5 unknown
5 unknowns وكم equation؟
6 equations
6. يعني شو اسمه هيدا؟
هذا improper هذا عفوا partial
هيدا partial. هيدا partial لأنه I have 5 unknowns بس only 5 unknowns only بس عندي 6 equations to satisfy. 6 equation of equilibrium. So this is partial. هلا whenever you have a partial case, you have 2 scenarios. Or equilibrium is impossible, or for the loading, for the type of load in this problem, we have equilibrium. How to make sure? You need to write 6 equations, okay? The first five equations will be used to solve for the 5 unknowns. And once you solve for all of your unknowns, you verify that equation 6 is satisfied. If equation 6 is satisfied يعني في equilibrium. If equation 6 is impossible يعني إذا طلع لكم مثلا 0 equals 0 يعني it's satisfied. إذا طلع لكم 200 equals 0 you say it's impossible. Okay? So whenever I have partial constraints, I should solve for my equations of equilibrium and make sure that the additional equations are satisfied. Let us do it here, okay? So the first step is to draw the free body diagram of my rod. What are the forces acting on my rod? I have the weight, which is 200 Newton. I have the ball and socket at A, yani AX, AY, AZ. And I have the tensions TE and TD. Okay. Now, what are my equations? My equations are first, sum of forces equals 0. Okay. So sum of forces equals 0 will be divided into 3 equations. Sum Fx, sum Fy, and sum Fz. So first, in X direction, what do I have? I have plus AX plus TE equal to 0. This is equation number 1. Along Y, I have AY plus TD equals to 0. This is equation number 2. My third equation is along Z. Along Z, I have AZ minus 200 equals to 0. Equation 3 will give me AZ. So my first unknown is determined. AZ is 200. But I cannot stop here because I have 4 additional unknown. I have 4 additional unknown, but only two equations here. So I need to write sum of moments. You can select any point on the figure, but the easiest point is A because you have 3 forces passing by A. So when you do sum of moments about A, AX, AY, AZ will not do any moment. You just have to account then for the moment of the weight and the moment of the tension forces. Okay. Now, remember, to find moment of a force in 3D, I have 2 possibilities. Or I use the right-hand rule. Okay. Yani for example, here, I have the weight here. The weight passing by this point. It's a vertical force. Because it's a vertical force, it's parallel to z-axis. I say the weight cannot produce a moment about z. It can only produce moment about y and x. Okay? So one possibility is to say, let me find the moment about by doing the right-hand rule. Let me see here if the figure... Okay. For example, if you want to get using the right-hand rule the moment of the weight, what do you say? You say this is z-axis. 200 Newton force is parallel to it, no moment. Okay. Now, if I consider the weight, so if I extend the line of the weight, if I extend its line, it will intersect the plane XY in a point of coordinate. I can find the coordinates of this point. Point C has coordinates of 1, 1, minus 0.5. So if I do the projection of the weight on XY plane, the coordinates of this point will be 1, 1, 0.
1, 1.
1, 1, 0. Okay? This means what? This means that this distance, the distance from weight to x-axis is what? Is 1. And the distance from weight to y-axis is also 1. So when I want to do the moment, take your right hand. If you do the right-hand rule about x-axis, your thumb will point in negative direction. Try to do it. Since it's pointing in negative x, so I say the moment of weight about x is minus 200 times 1. So minus 200 times 1 along I. Now, what about y-axis? try to do with your hand. If you do the right hand rule, you will find out that your sum will point in positive y. So it's plus 200j. And no component along k. This is if you want to use the right hand rule. If you don't want to use the right hand rule, you use the vectorial, the cross product. Okay? If you want to use the cross product, you have the weight is passing by C. So you can do AC vectorial the weight. So the other method is to say I do AC vectorial. The weight is minus 200k. Let us now replace AC vector by its expression. A is the origin of our frame, and point C has coordinates 1, 1, minus 0.5. So AC vector is I plus J minus 0.5K. Vectorial minus 200K. You can use the matrix, but here, since you have you don't have a lot of terms, you can do the expansion. If you do the expansion, you have first I vectorial k. I vectorial k is minus j, and I already have minus, so plus 200j. Plus 200j is my first term. Now, j vectorial k, it's plus I, and I have minus, so minus 200I. And finally, k vectorial k is 0. So if you compare both methods gave you exactly the same result. Minus 200 in I and plus 200 in j. This is for the weight. Now for TETD, same approach. I have two methods, or right-hand rule or vectorial product. Okay, so here they did the cross product, and after you do the expansion, you will obtain along I in total, you have TD minus 200 in I. Along J, you have minus TE plus 200. And along K, you have 2TD minus 2T. And now for equilibrium, what are the conditions? This should be 0. So sum of moment about x is 0. This represents some mx. This is the I component. And this term represents sum of moments about y. And this term represents sum of moment about z. Okay, now we need only 5 equations. Okay, so if you solve here, you get TD equal to 200. And from this relation, you also get TE equal to 200. Once you get TD and TE, going back to your previous equations, you solve for AX. AX is minus TE is minus 200, and AY is minus TD is minus 200. So you just need the first 5 equations to solve for your unknown. But how you can ensure that I have equilibrium? You should verify the 6th relation. For my 6th relation, I should have 2TD minus 2TE equal to 0. Let us verify this. From our solution, TD is 200 and TE is 200. So if you replace 200 and 200 in the equation, you get 0 equals 0. So your relation number 6 is satisfied. Then for this type of load, I have equilibrium. Okay, but if I change the load type, I might have impossible equilibrium. Okay. Question on this? يعني for example,
دكتور كيف بنحلها إذا بدنا نعملها ماتريكس؟
إذا بدنا نعملها ماتريكس بتحلها هيك. قصدك المومنت you mean؟
إيه إذا بدي ألاقي المومنت على A بس مش بهالطريقة.
اوكي، مثلا إذا بناخد الويت، إذا بدك تلاقي المومنت of the weight، بتقول باخد I J K. The first row is I J K. second row شو كانت؟ شو كنا نحط؟ البوزيشن فاكتور، يعني 1. بس ما راح تساع معي هون، خليني احط لك اياها هون. So you put I vector for the first row I J K. السكند رو هي البوزيشن فيكتور AC، يعني شو الكوردينيت له؟ 1 1 minus 0.5. the final row هي الويت، يعني 0 0. الويت هو minus 200 NK. و how you solve for this؟ ما بتعرف الماتريكس calculation؟ هيدي من من هيدي البارت.
ساعتها بعمل هيك لكل وحدة وبزيدهم على بعض.
100%.
اوكي ماشي.
Okay. Another problem. If the cable can be subjected to a maximum tension of 300 lb, determine the maximum force F which can be applied to the plate. Compute the XYZ component of the reaction at hinge for this loading. فإذا هن عم بيقولوا لنا إنه الماكسيموم تنشن اللي بيتحملها الكيبل هي 300. فبدهم إيانا نشوف شو هي الماكسيموم force that can be applied. When I apply F maximum بيطلع لي بالكيبل 300 lb force. Okay, so my unknowns are the maximum force to apply. وقلنا الhinge, this is a hinge. It's like the door connection. The door connection will only allow rotation about this axis. يعني ما بتعمل هيدي الconnection، ما بتعمل moment about y. But it can do all other types of reactions. يعني it will do MAZ, it will do MAX, it will develop force reactions in X, Y, and Z. يعني هون عندي 5 unknowns already. Plus F is unknown, عندي 6 unknowns. So I am in the case هيدا normal problem. 6 equations, 6 unknowns. Okay? So now I should write my equations. First equation هي sum of x equals 0. I only have one force in x اللي هي AX. So this will give me AX equal to 0. Along Y, I also have only one force along Y اللي هي AY. So AY should be 0. Now, along Z I have several forces. And the plus TBC اللي هي 300. Minus F to calculate, and plus AZ equals to 0. This is equation number 3. But in this equation, I have 2 unknowns. يعني I need to continue further to solve this equation. Next step, I do sum of moments. Okay? هلا هون فيني أعمل sum of moments. I have several approach here. فيني أخذ origin O of the frame واعمل sum of moments about O equals 0. وفيني كمان اخذ A as point. يعني بس اخذ A as point كأنه اخذت X axis passing by A, Y axis passing by A. فيني سميهم X prime إذا بدكم. X prime, Y prime, Z prime. يعني هن مثل X, Y, Z passing by O بس هن passing by A. Okay? And here I have also 2 ways. Or I use the right hand rule. Okay? Or I use the cross product. هلا هن بهيدا الاكسرسايز عملوا الرايت هاند رول. كيف عملوها؟ جيت قلت first if I consider sum of moment about this axis, the x axis passing by A, x prime axis, what are the forces that can do moment about it? أول شيء AX, AY, AZ are passing by this axis, يعني no moment. So I can only have the moment of force F and the moment of 300 lb force. Okay? وبما انه هول الفورسز are really simple، يعني هن vertical I can find the moment using the right hand rule. طلعوا منيح. At that distance هون, the distance between F and this axis is just the perpendicular, this one. هيدي اللي هي 1 feet. بينما ال 300 إذا باخد ال perpendicular distance, this is the perpendicular distance to X prime, it's 3 feet. Okay, and if I do the right hand rule with my hand, this force will rotate in negative X. عملوا right hand rule. Your thumb will point in negative X بالل 300. بينما ال F is downward. يعني إذا بعمل right hand rule بيطلع my thumb pointing in positive X direction. So it's plus F times 1. فإذا عندي minus 300 times 3, okay, minus 300 times 3, plus F times 1. This will give me a moment about x-axis passing by A. وشو في عندي كمان? Don't forget please الكابل moment. عندي MAX, I should put it. يعني أنا الإيكويشن اللي كتبتكم إياها هي about x-axis passing by A. هن عملوا غير شيء. هن أخذوا some of moment about x-axis passing by O. If I want to take moment about x-axis passing by origin O, then TBC will pass by the axis, no moment. Then I have to consider the moment of F. طلعوا ب F. عملوا right hand rule. The F is doing a negative moment. So minus F times this distance. Minus F times 2. Okay. So this is the first term. Now, AZ is producing, if I do the right hand rule, AZ is producing a positive moment about x-axis passing by the origin. The distance is 3 feet. The distance is, from this point to this one. So from AZ to the axis, this is 3, لأنه 2 plus 1. This is 3 feet. So the moment of AZ about axis passing by O is AZ times 3. والكابل قلنا على طول بنحسبه. يعني this couple is along x-axis. Wherever the point I do some of moment about, I should include MAX. And since according to the figure, okay, I assume a direction for MAX. If I assumed it to be in positive X direction, I put plus MAX. If I assumed the couple to be in negative X, بحطه minus. And then if I solve, if I get positive result, my assumption is right. If I get a negative result, my assumption, I should take the opposite direction. Okay? So here you have the freedom to consider any 3 axes, X, Y, Z, passing by O or passing by A, اللي بدكم إياه. Okay? And then if I use the right hand rule, I can write 3 equations, one about X, one about Y, one about Z. For example, if I take about Z, all forces are parallel to Z. يعني إلا مين؟ إلا AX. Okay? So if I take some of moment about this axis, this Z axis, all forces are parallel to it, no moment. بس في عندي I just have the moment of AX to consider.
But we have AX equal 0. ما فينا نقدر نقول إنه خلاص مش هينفع.
بس لأنه AX is 0 from previous step, يعني this moment will cancel out. And don't forget to consider the couple in Z. عندي plus MAZ. So from some MZ equal to 0, I deduce that couple MAZ is 0. Okay. So, and now I need a third equation. The third equation is sum of moment about Y. If you consider Y-axis, this is Y-axis, okay? AX and AZ are passing by it, no moment. So I just have the moment of F and the moment of TBC. If you use the right-hand rule, the moment of F is positive, the moment of TBC is negative. So I multiply F by the distance. plus F times 3 minus TBC times this whole distance اللي هي 9 feet. I get my third equation. And then I have 6 equation, 6 unknown. I can solve for all of my unknowns. Okay? إذا ما بدكم تستعملوا the right hand rule method, you can use the vector, يعني you can use to get the moment of any force about a point, you can use the vectorial product. You find for each force the moment about, let's say, the origin, and then you do at the end summation of moment about x0. You sum I components together equals 0, j component together equals 0, and k component together equals 0. You can try the two methods. The two methods will give you exactly the same result. Any question on this? So this is the chapter of equilibrium of a rigid body. Of course, we'll do problems together to practice on it. Okay? Any question before we stop?
Thank you, doctor.
Welcome. Bye-bye.
Thank you.